Welcome, everybody. May 10th, back for another roundtable. And we will start with Leap software update. Stephen is out today, so we'll hand it over to Brian to give us the update on the software side of things.
Excellent. Yeah, so we have a couple of more firm things and one looser sort of update. So PPT v 4.0.0 RC2 will likely be landing early next week. That's what we're currently targeting for that. June v1.2.0 also will likely be landing early next week. And then Leap itself, we have a patch release planned. So there's been a few defects discovered that we're fixing currently. We don't have a date for that patch yet, but as soon as possible, that'll go out. So I'll keep folks abreast in the channels. And that's it as far as updates go. With that, we'll likely end up heading back to the node types discussion. I also have some topics here that we've sort of generated from a previous conversation that I want to review at a top level to see if any of those are still relevant and if we should discuss them further than we have to date. But before we get into that, I did want to talk briefly about running, EOS EVM nodes and sort of like what explorations or participation people have sort of looked into there, and what would what sorts of things would help in that area. So yeah, I'm going to leave it open-ended. Has anybody on the call yet started running the EOS EVM nodes?
Was there a request to run the EVM nodes?
Nope, not to date.
Just thought I'd start with that one.
Mm-hmm.
I had somebody ask me about it, but no, we haven't tackled it yet. I think we took a look at it.
And so let's say that
I know Stan set it up because he commented in the channel that he set it up, and he opened a bunch of GitHub issues with documenting challenges he ran into. But
yep. So if we were to put out and say like, hey, ideally every node operator is running this stuff, what might make you likely to actually do that? What might stand in your way? Those sorts of things.
My first answer would be good luck to get everybody to do it.
Well, I would say the same thing, because how many of this is EOS, right?
Mm-hmm.
So how many of the existing EOS node operators are running public? I assume you mean public EVM nodes, not private ones.
Public anything.
Right. So, I mean, the number of people in that category is somewhat limited.
Yep.
So
Ross said he'd do it.
Oh, okay. Cool. Well, I'll rely on Ross.
Yeah, I just threw out. I have no idea what you're talking about. You showed up late. It's not.
You arrive late, you're in charge.
Did I win a prize?
Absolutely. You get to buy more hardware at your own expense, run the EVM infrastructure for everybody on the whole planet.
Mm-hmm.
The OVH will scale. It's not a problem.
Is that a little Docker image, isn't it? Yeah, you go with the doing it. Yeah.
But seriously, Brian, what's the incentive to run the infrastructure? Right. So in the early days of the EOS land, it was like, well, BPs, need to participate in the ecosystem and mobility community or whatever. And that was the incentive. That ship kind of sailed. So now what's the incentive?
Right. Well, I'll turn that back around. What sort of incentive would need to exist to make it worthwhile?
Something to pay the bills.
Yeah, I think that's the minimum, right?
I'm not even gonna say it's the minimum for EOS USA, but hey, that's nice. I mean, a project that's actively, for us, it'd be just a project that's actively engaged and wants to use it. You know what I mean? I'll run whatever the hell if you're willing to give it a shot and use case it, but
that's give it a shot, not like make it available for anybody. Oh, maybe you are glutton for punishment and, having.
EOS USA is probably a little more likely for that than many others because they're on-prem.
When you say
probably need a service that checks these public APIs, like what US Nation was doing with the validation stuff. Like you're gonna need some service that's gonna check that these nodes are actually running and they're not problematic, and then potentially work out something where they get some of the gas fees.
I think that's the way the EVM node is built, right? I think it automatically has some sort of operator collecting some gas. I haven't looked into it. I think I remember Stan posting about it, but I think that's some mechanism to it. But yeah, I mean, nobody's going to be using it. It's probably going to require, a decent amount of hardware and
yeah,
I'm sure it'll get abused. What were you asking? You were asking something.
Yeah. So you said that for you would need a project that is actively engaged and wants to use it. I wasn't sure what you meant by a project.
Our threshold for operation is a little different than a lot of others because, a lot of our hardware is already capitalized and I mean, kind of what we did. But we aren't just an absolute glutton for punishment as much as they may seem. So, we spin up technologies and kind of help people get going to even get started before they can afford whatever it actually is, a rack of I-9s to do it. But, we hopefully help jumpstart them as opposed to happen to have some immediate funding. Now, if the network itself could find some funding, that's optimal. But that's kind of Shaq's point is then you get into the game of, well, is it really working? How much is it used? How reliable is it? This, that, and the other.
Right. But what I'm still not clear on is when you say project, do you mean an internal use case or do you mean like a client?
Any use case. Somebody says, I want to use an API and somebody did. One person did reach out and say, hey, I want an EOS API. Ironically, they just wanted a shortcut into the peer-to-peer network for their transactions. But anyway, long story short, I mean, there are some projects that are investigating it, but just a use case that we can, all right, sure, we can throw $10,000 worth of servers at it. Why not?
Well, I suppose we are block producers. We get paid programmatically by the actual chain itself. If this would improve the value of the EOS token, it makes sense for us to run it, right? Yeah, and you kind of support yourself to get more use on the actual EOS network, and the value of the token go up, et cetera, et cetera. So
that's tied into it. Yeah, I mean,
yeah,
somebody to get some value out of it. Doesn't even have to be purely financial.
Well, for us, we're running a business. We want to make sure that there's value, and that value leads to growth of the ecosystem.
Mm-hmm.
So yeah, that's it.
So
Where does this all
roadmap, maybe, or
Well, I mean, I guess maybe
We can give it just like for people not familiar with what is this infrastructure that is needed to run for the EOS EVM. Are you talking about like just API endpoints to use with like MetaMask stuff? Are we talking about like APIs that is like reading within the EOS EVM contract and like, exposing some common things people want? Like, what is it exactly?
Yeah.
Then maybe people will be able to, because they're just running another, small kind of service. When, the EVM is not really used that much, most people won't mind just adding it to one of their servers. But, it really depends on the scope.
Right. So there's kind of two sides to it. One is JSON, the RPC piece, and the requirements for that, as it's currently implemented, is that you need to have an in-sync ship node, and it also has some sort of heavy lifting or like indexing and whatnot that happens there. And then the other side, which I admittedly don't know a whole lot about, is at this stage, I'm still learning, is the miner in quotes, because it's not mining like other EVMs, but basically that pushes transactions into the EVM.
Like, isn't the RPC endpoint the URL that the user is going to set within their MetaMask?
Yes. Yeah.
So is it going to be like you're providing like load balance, like basically maybe there will be like a load balance, endpoint, and that goes out to the different providers? Or how are you even, like if you're running one, how are you going to get people to actually use it? Because people are going to, add the network only once, most users.
Yeah. That's a fair point. So like at a higher level, like how do you even, because in something like MetaMask, the RPC endpoint is sort of synonymous with, quote, the network. So yeah.
Well, a load balancer would work like some type of, round robin or least connected or something. And that will also, whoever is running that load balancer will be able to figure out who is getting what calls, as well as who's responding correctly. And if one fails, move to the next one. And those statistics could be used to derive who should get something out of, say, a certain pool of gas fees or something.
That's been discussed on many of the different networks because of the same type. I mean, even just standard Node.OS APIs is to have a network common address, which is intelligently load balanced and managed across in and out BP network, and validated that it's functional. If it lag behind, you don't want people, and it does happen, and it causes people weird things. Is they'll get every other response, they'll get a weird response or something like that, and using that towards trying to know who's doing the work and using it for billing. But as you can imagine, that becomes a pretty massive product and service, because it's so critical, and becomes the central point of both, attack mechanisms, and or somebody centrally has to manage it in a decentralized.
Yeah, and on top of that, if someone is like, say, their ship history is behind or something,
right,
and it's kind of their turn, MetaMask makes like 1 billion calls. Like I wrote one like, RPC for kind of like Antelope for it. And it makes like so many calls all the time to update all the assets for the different, accounts that you have. So if, for example, some of these go to a different load balance server and the ship node is behind, you're going to see your assets values just changing randomly. And like it needs to, like whatever, if a proxy is to be set or a load balancer, it's not going to be your just like nginx and boom, round robin and you're done. It's going to have to actually find a way to check the current head, verify that whatever API is going to proxy to is actually in sync and, can answer correctly.
So and then geo load balanced all over the world, things like that. Just it becomes this massive product of the network.
But this would require like good health checks, like the stuff that you guys are describing, where it's caught up and ship is responding and all that stuff. Like we should build that into a good health check, and then the load balancer would only serve traffic to people who are passing the health checks, which is a problem that we're still working on, to be honest. But we are using load balancers for this, and we have health checks. So
Correct.
Well, also, I don't want to get caught up on one solution like load balancing to different node operators, because it might be that that's not the right solution. I don't know, right?
So my question is, do we want to optimize for reliability or decentralization, or some mix of both? Like, one solution might be there's one operator that has a contract that has a highly reliable, redundant RPC node, and it's just a direct contract with the DNS to, like an insurance type of service.
This is a Brian statement, not an ENF statement. But I would say, like, based on what I know about, how EOS is seen, right? I think we're better leaning into like speed and performance than decentralization as the selling point, right? And reliability, I meant to say. And so that's my gut. But that said, that's why I said I don't know that load balancing is necessarily the right solution, because I don't think we necessarily have to only do one or the other, right? Like, people could provide alternative points,
Sure, but then, like, when people go to the EVM official, say for example website, and click add to MetaMask, whose the address isn't going to be there, because you can only put one address, and once it's there, people are not going to change it. Like,
Right.
which is very
Look at Anchor and GrayMask. I mean, we all run nodes that can run it, but everybody uses GrayMask because that's what it out of the box.
I'm kind of like,
at least with GrayMask, you can, sorry to interrupt, but at least in GrayMask, when you're using WAR for EOS on the front end, you can specify your own kind of API endpoint. So a lot of people are actually using different ones from the site, which you could kind of do with MetaMask. You could prompt the user to add the network again, but if everybody does that, it's going to be like, they're going to have a ton of networks into MetaMask. It doesn't make sense.
I would venture to say, if the ENF kind of has a big initiative to try to get, the EVM projects going on EOS, to maybe look at having a standard load balance, whatever, simple, that key providers could, sign up for it. It does its health check, as long as you aren't, doing bad, whatever works out, and offer that to the community as the default address, and be able to say, look, if you want to use your own, whatever. But I mean, from a marketing aspect, I think you really need to try to make it as easy as possible to add it to MetaMask and not have to go through all the different addresses. And
a provider.
Most people are okay with, if you have a need and have a budget and requirements, let us do our thing, prove our reliability, and participate, and hopefully get compensated for it. So I think you would find a decent participation worldwide. Just saying, I really want some good API providers.
I really like the idea of like us coming together and like providing a single endpoint. I think that'd be really cool. Like, that's so awesome that you guys suggested that. If we put a bunch of different endpoints behind the same load balancer, because right now we have it in 2 regions in the world, but like the block producers are everywhere. So if we had it in all these different regions, it'd be so much faster and better for people. And, if you guys wanted to publish, like, if there's an issue with the load balancer, you can connect directly to us this way. Like, that'd be cool too. But I don't know. I think this is a cool suggestion. I'd love to work on something like this.
If it's an ENF initiative, that's good enough for us. We can figure out how to pay for it later. That's our threshold.
And I think it's the only solution, unfortunately, the load balancing for the end user experience.
Correct. Comment.
Daniel's point.
Suggested address.
I'm not suggesting no form of load balancing, but like, I can't imagine different users having different sort I'm looking for priorities. And I'm not saying this is a thing we should do, but like, I could imagine, okay, do you want maximum reliability or maximum decentralization, right? And therefore you're going to have 2 different sort of options for, one's like, just push this button and it'll add to MetaMask. And the other one's like, okay, here are a bunch of RPC endpoint options. What do you want to do? Like,
have you ever added a custom to a public task? I mean, it's rude.
Yeah, I have. It's
But-
it's not that bad, but I agree that it's certainly not massive.
It's fine, but editing it every time is not fine. But what you would do is basically you would publish a page where the users add it to MetaMask, where you say, here are all the providers, and that is the decentralized providers, so say all the BPs that are willing to do that. And then on the top, the only one that has, for example, add to MetaMask, this is a proxy for all these different providers. So they realize the decentralization of it. And you can have, say, multiple endpoints on different domains, for example, like that are proxies also. And then the users realize this. It's like in Fura, from an endpoint of a user, they don't care about decentralization. They all connect to, in Fura and Ethereum, and that's it. For them, that's their source of truth. For us, it's a level even deeper because it is decentralized in the sense that behind this proxy, yes, that, domain is controlled by one person, but behind the proxy is actually leading to very different services that are all being checked to be consistent, basically, on a head and so on and so forth.
Okay.
All right.
I'll go back to a comment I made earlier, which aligned with kind of what Ross has said, is what's the roadmap? What is the need for all these EVM RPC endpoints, right? So when we started with EOS, there was like this white paper that said, okay, here's what we want to do with the network. Okay, well, that all fell through. We all know the story, but at least there was a vision right here. Oh, there's EOS EVM. Okay. Is there a white paper? Is there a blue paper? Where's the plan? Then we can see, for XYZ to happen, it means we need node operators to run RPCs. This is how they're going to get paid. This is the vision, right? And then it's all laid out. And then we can see how we might or might not want to play a role in that vision.
Yeah. Yeah.
Or maybe it's been laid out somewhere that I'm not paying attention to, which is totally possible, because I'm not.
We need the what's the word I'm looking for? The momentum that comes with sort of when you have a movement, so to speak, right?
Mm-hmm.
Like, where people are bought into a shared vision. So yeah,
Yeah.
there you go. Okay. On the roadmap, I'm assuming your reasoning for that is exactly that, like to create that sort of shared vision, and or is there some other reason that you're interested in?
What do you want me to do, and why do you want me to do it?
Yeah, well, yeah, that. But more practically, there's 100 EVM chains out there. Just because EOS has an EVM, why does that put them more important than, I don't know, Avalanche or Polygon or whatever, right? So,
Or Ethereum.
or insert the one you want. I got a message yesterday. Hey, we're starting up a new EVM chain. You want to join? Like, okay, well,
Send it away.
so incentivize me to want to do something on this chain. Other than, increase the price of EOS, which wouldn't help us as block producers.
Right.
Right. So
Like almost like you want to see it attracting projects that projects are moving from, say, Ethereum because they need whatever more performance, lower fees, or whatever the reason may be, and you kind of have a place where you can track that this is actually bringing in users or see the benefits, kind of thing. I'm just trying to understand your point, Matthew.
well, it's not that we have this. I don't understand what the vision is yet. Has it been laid out? Right. So I have a million things to do in my day. Why do I want to prioritize setting up an EOS EVM versus setting up a XYZ chain EVM?
I think the whole point, at least how I see it for EVM, is not like, hey, look, we're an EVM chain. It's more to just, get outsiders, mainly, people from Ethereum or other EVM chains, to come and try to use it here at cheaper costs and more performance, and then benefit to eventually convert to proper EOS smart contracts. I thought it's more like a funnel.
Is that the vision? I'm not sure that's the vision. Right? Is the goal to convert everybody? Dear everybody, dear world, come here, get your thing running on EVM on EOS. Oh, wait. Now actually convert everything again and run everything on native EOS. I don't know.
It's not convert everything again. Like the whole point is they can take their existing code and run it simply on EOS and gain,
I get it.
And gain advantages already where some of these projects may be running into a lot of limitations on their, wherever natively they developed it. And then once they slowly, because it's not going to be a magic wand like, hey, convert, once they slowly see these benefits and then get more entrenched in the ecosystem, they can slowly start migrating their most, say expensive tasks to another smart contract, and then eventually migrate their whole thing. So it's more like you're providing a ramp up kind of for these external users that wouldn't otherwise come and learn EOS. Now they have a way to actually get on it, gain some of the benefits right away without learning its ins and out, and then have a path to even expand on that much more in the future. But that's just my view. I don't know if that's parts of vision or something. Also the ENF or EOS.
Well, that's the thing. I don't know if that's a vision or not.
That's my personal vision, like speaking as an individual and not the ENF. Like that's how I see it working. I identify 100% with what Shaq said.
So I'm playing a little bit of devil advocate here, in case you didn't guess, right? So I'm just throwing swords or whatever onto the I want to see this thing succeed. I would love to have a reason to run it. Tell me what it is.
Yeah, for that matter, first of all, I appreciate the candid discussion because that's, I think, where the best value comes from. And if you notice me being silent, it's because I'm actually getting a lot of value out of hearing you folks talk to each other about it.
So over the last year, I've played around with a bunch of EVM chains. So, I spent the last year doing that rather than, EOS more specific things. So
which one do you like the best and why?
I'm not sure I like any of them the best because I'm only looking at it from a node operation point of view. I'm not looking at what happens on chain. I care how easy it is to operate. How does the consensus work? How does the software work? How does it back up? How does it restore? How does this thing scale? Does it work? Does it always crash? Does it work with the latest Aragon? No, the thing crashes. Oh, you have another custom stack I need to run just for your EVM chain. Great, another thing to learn. Thank you. Right, so all these EVM chains popping up, I'll do it this other way. Great, another thing to learn. Right, so the EOS EVM, I get to know, okay, now I have to learn this Silkworm thing. I'll figure out how to run that. Great, thanks. Right, so that's what I'm looking at. So I don't have a favorite. The favorite one that I would have is the one that's the most boring, that requires no work.
So, question to you there. Would you appreciate it if we provided something like Helm charts or even just Docker containers that you could deploy without having to worry about what they are? Or is that not something you're interested in? Because I know a lot of you guys run bare metal.
Well, not speaking specifically for myself, but there's 3 types of users that are node operators that I've run across in my year of working on this stuff. There's the run everything in bare metal and don't give me any of this Docker crap people. There's the I have a simple Docker setup. Please just give me a Docker Compose thing. And there's the I have everything in Kubernetes. Just click a button and I don't care. Just make it work. Right. And the amount of attention people spend on their nodes, decreases between those 3 options, I would say. Right. So I want to run everything on bare metal. Those people really care how it works or are optimizing it, making sure it's performant. If it's click a button and deploy it in Kubernetes, then, they're not really paying attention to what's happening. They're just set it to latest and let it automatically update and you don't have to do anything. I tend to be in the first bucket, but I want the first bucket to kind of work like the third bucket. Right.
I think most VPs are in the first bucket. And the other groups of Docker or Kubernetes are more or less like the same in a way, because at the end of the day, Kubernetes is going to use a container system like Docker.
Yeah, it's just more animated at more scale.
Yeah.
That's all.
Yeah, exactly. And I think you guys use not Docker, but use like Containerd, right?
We're using L1 bare mailers ourselves.
Yeah. Okay. Fine. So I think, like Matthew said, like the important part is not necessarily that it has a Docker image. That would help some people run it, I assume.
For sure.
Somebody who's going to benefit, but something that could be run also on bare metal, simply updated easily, has like clear tools to back up, restore on error, on crash, like something that's like stable to run without too much messing around is, I think,
So one of the parts of running the node infrastructure that I find is you have to get a feeling for how it works, right? So it's not just set it up and let it run. You have to understand, okay, when it's overloaded, this is how it behaves. When you do a consensus upgrades, this is how it behaves. These long messages are, you just ignore them, who cares? But these ones tend to be important. Or what's the alert levels? When does it get behind?
How fast the disk storage may grow.
Yeah, exactly. Can I run it on another
ahead of time?
Yeah, exactly. So all of these kind of things, you don't typically you can't automate all that, right? So you have to just learn how it works and you get a feeling and you play with it. Then after a few months, then you're gonna like, okay, now I understand how this thing works. And then you're like happy, and hopefully there's an upgrade process that follows always the same way exactly. So then you just have a recipe and your playbooks can just run and deploy the thing automatically the same way all the time. Right. But there's a learning that goes to it.
Requirements and growth is just like very helpful. Like this, like the main question I would have is like, how much disk space does the indexer that indexes, I assume, some type of, database, and all the stuff, how much is it in its current, in its current form, how much it grows over time?
This is always the first questions and I have a node, right? How much CPU do I need? How much disk space do I need, right? Because if you're running on Hetzner, you have to buy the right, or, rent the right machine. Do I need an AX101 for this? Oh, or no, one of these other ones, right? And it costs money if I have to change. And the RAM. Yeah. So having those, give me the hardware requirements for the next year is definitely helpful. Which of course requires some crystal ball, because who knows what a year was from now. But
yep. So just to try to restate what I just heard, one of the barriers is a lack of understanding of what the hardware requirements would be, right? Like how much CPU do I need, how much disk space, and what's the current and projected growth rates for those?
Well, okay, so who are you? Depending on which kind of operator you want to attract, you need to give more details or less, depending on, who you're trying to do. So if you give us $1 million a year and tell us to run a node, I won't ask you any of those questions, because you give us some money, I'll cover whatever resources you need. Okay, I'm exaggerating, of course, but if you're, dear little guy, please run my thing, and, you're getting $50 in gas fees a month, well, they need to be really clear about what is the requirements to run that node, because is it worth the $50 or not? Right? So where's the return?
Right.
Now I'm like Michael.
It's gonna be like APIs, like where we're just gonna shame people who are not running it. Like that was the method back then: shame people and hope the voters do something about it. We saw how that went.
Yeah, well, that's not gonna work, right? We're not incentivizing anybody as
Centralized or reliable.
Yeah, right, exactly. So I'm like Michael, I'll run infrastructure even if it doesn't make a profit. If there's a vision that, it's helping people, it's going to grow the ecosystem, there's a bit, yeah, sure. We don't have to make a profit on it, but it can't cost me, right? My time is the most valuable thing.
If you pay me.
Yeah, if you pay me, then the requirement for believing in the vision goes down, right? The more you pay me.
On the mining side, and so I know most folks here operate often as block producers. On the mining side, if we assume that there's just ignore any diminishing returns on number of miners who are pushing transactions in and whatnot. So we assume that the most possible is the best, right? And this might be speculative, let me know if it is, but what do you think the receptiveness of folks who are kind of in standby and lower positions as not node operators to running those sorts of things might be? And if you don't know, do you have any suggestions on how I might find out?
Well, first we need to know what mining is. Is this like proof of work mining where we can accelerate it to the GPU, where, we can use an ASIC, where like what algorithm, like that would really affect, because if it's just
basically a queue processor, isn't it? I mean, it's just a little Oracle.
Michael, I didn't hear you. I'm sorry.
Oh, as I understood it, I mean, basically it's just sitting there waiting and receiving transactions and smashing them into the chain, kind of like a Oracle processing.
It's like a transaction relay node, and then not actually doing any block property, like any block mining and stuff, because right now it's under EOS, so there's no block mining, no consensus layer. So it's really just a transaction relay, the fastest transaction relay. But ideally, if there was a load balancer that would proxy, based on different requests, then whoever was essentially load balanced, proxy targeted would get the sort of that first response. But it could be another VP that could probably pick it up as well, depending on how the load balancer works. But from my understanding, it's more of a transaction relay node than a miner shifting work.
So would it make sense to have a scenario where it's like the RPC endpoints is a monolithic Infura type solution, and the RPC and the miners are more decentralized?
Well, the monolithic is the load balancer.
The RPC is the big one, right?
The load balancer is the central point. And this is, I think, I'm sure Infura is like that too. Like they probably have multiple different providers within their infrastructure, but they have one endpoint, and that one endpoint does the sort of like load balance. I think the graph is like that.
But would the RPC and the miners both be behind the scene load balancer, or are these two different things completely? Like, is there a scenario where you have RPC endpoints behind a load balancer, or miners behind a load balancer with a decentralized set of operators, and an RPC endpoint that's just one provider?
Well, the providers would have their own load balancers. So let's say like Michael would have their own load balancer within their own infrastructure connected to a higher load balancer, which kind of does that global redistribution. And it's only because the users can only put one address, and that one address is, it's whatever that one address user puts will be the first point of contact.
Right. And that's for both the RPC endpoints and for the miners. It's not two different addresses.
You could go directly to the RPC endpoint directly, or you can go through the sort of the global proxy. And I think that was either Shaq or if it was Zach that mentioned that you would list all the different providers. You can go and connect directly to them, or you can connect to that higher level load balancer, which is essentially all of them combined with the round robin, the priority time.
Here you're still talking about the provider's proxy. I think Daniel is asking about like the miners. Like I'm still not clear what the miners actually do, because now seeing is kind of like acting like an API that's just relaying stuff to the node, but it's relaying it from where, what authority does it need to actually write this data to the blockchain? Like how does this authority change, or the schedule of these miners? Like it's still very unclear, to be honest.
To be clear, that miners, put it in quotes, I use that term simply because it's achieving the goal that miners on other networks would achieve, which is getting transactions included, right? But it's not doing the activity that miners on other EVM platforms.
So they're not competing. It's going kind of in a round robin between the different people in the miners, or like they're not.
Another frank thing is like I still have learning to do here. I don't fully understand this part of how.
So the miners are which transaction tool, basically.
The way it works is that there's an Ethereum transaction that comes in, right? And so that Ethereum transaction needs to be wrapped into an EOS transaction, and then the EOS transaction needs to be submitted to the network, right? So to do that, obviously someone has to pay the CPU and net for that transaction. So the miner is the one paying that CPU and net for that EOS transaction that wraps the Ethereum transaction into the network. As payment for paying for the CPU and net, then the miner gets gas fee, which has been paid in the EOS or in the Ethereum transaction.
Right, and this is why there's an advantage to having more miners, is because it distributes the fees and also the rewards, the gas fee rewards.
So it works similar to kind of, I don't know if you guys are familiar with the Ether account by EOS Argentina, where, you have this smart contract on chain, EOS account, Ether account, and then, using MetaMask, you talk to a custom RPC endpoint that what it does is takes the, say that the transaction of a normal EOSIO transaction and converts it into like an RLP type and pass it to the smart contract, charging the user for the fees of CPU net and even potentially buying Gram, and then sends back this fee at the end to whoever pushed it. In this case, it will be the provider of the RPC endpoint. So if it's similar to that, from what it sounds like, the RPC endpoint provider is the miner.
Yep, that's from my understanding. It's just the transaction, that essentially whoever pushes the transaction would get the fee collected for that transaction at a ratio, because there's also RAM included as well. So the smart contract itself, so EVM would pay for the RAM, the miner would only have to pay for the net and CPU.
Yeah, so it's one, I'll call it service, if you will. Two separate jobs, one service, right?
Right.
So it's just one endpoint, but
So maybe the separated as two things is really one thing.
Is one thing. Yeah. So if we did have an Infura solution, the Infura would be the only miner. They would be providing the RPC endpoint, and they would also be mining every single block. There's no way to separate those two.
But we need to make sure then, like, that the software, because the software is going to need to estimate the CPU and net before it puts it. So usually, like, I would use compute transaction to figure that out. But then compute transaction needs to point to an endpoint that is similar to what the producer is going to process. So basically, all these different miner/RPC endpoints will need to point to similar compute transaction APIs, or else every time it goes around, you're going to get different estimates for CPU and net.
I think that's a fix, maybe.
Okay, it's fixed for the Ethereum. So it doesn't matter. Like, you might want to do that in terms of, like, if you wanted to not mine particular ones, I guess. Like if you were going to distinguish between ones that you were willing to mine and ones that you weren't willing to mine, depending on how much CPU and net is something cost you, right? I mean, obviously you could do something along those lines, but the idea is that, it's a fixed price that you're going to pay for mining that. And then, technically make different amounts depending on the actual CPU and net required for that given transaction.
So it's a fixed, so basically, when MetaMask is going to send an ETH get estimate, like call to the RPC endpoint. So the RPC endpoint at this point will have the transaction in kind of MetaMask style, or like Ethereum style. Yeah. And using that, normally what I would do is, convert it to this RLP stuff and do a compute, to figure out how much it would actually cost. But here you're saying that just from that transaction, I can have like a fixed formula to determine what I should return as the gas fee.
Yeah, so the transaction routing right now is just hard-coded to return the value.
Okay.
And there's a buffer, right? So it's you are spending less CPU than the profitable. The estimate is that you're be profitable. You're not like in a negative every time you push a transaction.
Right. So the fee is enough to where no matter what the transaction is, you should be able to cover it with the CPU and net and still be able to pay for RAM costs that are associated, although that's paid by the contract. You don't pay the RAM costs. And then, there's still a buffer there for actually making a profit on the call.
But if I'm running my own endpoint, I can choose my own gas fee, no?
Yes, it's a contract level. So I think the gas fee is it's EVM system contract enforced.
No, the gas fee is going to come from the node provider, no matter what. It's going to call the node provider and tell him, give me this estimate gas.
No, but what is billed? I mean, maybe that's more of a question for the...
Yeah, what build is going to be fixed now.
Yeah, but
if you charge on a through a MetaMask, exactly, that's the point.
I think the user is just, well, again, that's more of a really deeper question. Maybe from the...
So you decide what to charge, because at the end of the day, the MetaMask is going to make just this EOS estimate gas call to your RPC, and you can return whatever value you want based on whatever you want. And that will be the fee that they see on MetaMask and that they will sign, that they want to pay. Now, if that fee, like the smart contract could do something where, it determines the real fee and maybe returns that amount to the person or charge, it could find another way. But under this paradigm, yes, only the provider dictates what the fee is, because MetaMask is only talking to that. And that's what its UI and the transaction it provides to you to sign will show.
Yeah, I think maybe the smart contract is where there's a minimum. Maybe that's the only enforcement, and then the rest is a percentage. So if you do charge higher, or let's say the user opts into a higher gas fee, they would just have to spend more. There was no actually priority, and then there would just be a percentage. But the smart contract for the EVM would have a minimum gas fee allocation. I think that's what's enforced. Yes, you could have a higher fee and just bill the user more.
That's another check for you, Zach, for your health plugin. Check what the estimate is and make sure the APIs are not abusing their users.
I'm sorry. I was actually talking to ChatGPT. Can you please restate that again?
Getting more information than that. It was about the gas fee. Maybe check. You want to raise that?
It was about that the gas fee and the fee that MetaMask is going to pop up and allow you to sign is only dependent on the provider, the RPC node provider, because he's going to answer that estimate gas call from MetaMask. So they can put whatever number they want. They can put I'm going to charge, 1,000 EOS, or whatever it is. And that's what the user will sign. And if the smart contract doesn't have restrictions, that's what will be pushed also to the smart contract. So I think maybe in your health, endpoint, the stuff that you would need to check against to make sure that that MetaMask or that RPC node is part of the proxy list is to check that their estimate gas makes sense, like a constant check where you make sure that their estimate gas is not not overcharged should be.
Within one standard deviation of the others or something,
for example. But if it's a fixed formula, then it should be, kind of fixed. But maybe some tolerance.
Okay. Thank you. I'll write that down.
Currently, the software that's provided grabs that ETH gas out of the contract and provides it up. But I don't know offhand whether we then enforce the fact that it has to match. We could definitely do that in the contract. It's just not allow a gas fee unless it matches what we're expecting.
Because take care of that issue at least.
Yeah, because otherwise, if you leave it to the operators, then operators will do creative things because, they can change software.
Yeah, and I'm not sure. I'd have to dig into it, and I don't remember if we enforce that or not, but we definitely could.
So there are, obviously some questions and speculation about how things work. Just testing. So I know this is kind of in a middle area. So what I've heard is, clarity on how to participate, clarity on the vision and trying to achieve a shared community vision. What, I guess this goes into the how, but the requirements, what's it actually going to take to participate in this. And then, of course, a lot of questions about the specifics, right?
Yeah, and I would also add then the target audience. So if you want a ton of little providers, like I want 2,000 validators because that's a metric. Okay, you want 2,000 RPC providers? Well, that's a different requirement than I want, the existing top 10 tech EVPs to run it. Right? So if we look at the early days of the EOS came with a Docker image. Right? Back in version 1, there was a Docker. It was provided. And then at some point, somebody made a decision that this Docker image allows too many people who don't know what they're doing to run EOS, and it generates a pile of questions which we don't feel like answering. So therefore, we will remove the Docker. Right? Because that's what it did. It made it easy to run the EOS software, or the Node.js. Right? So if you want that kind of behavior, then you need to deliver the software tooling to account for the audience that you want to run the software. That was my, long description.
And also one thing worth noting is generally an RPC endpoint is not using much in terms of resources. It just
Yeah, but you got to run a whole ship node behind it.
No, that's what I'm getting at is you need to have access maybe to a ship node.
Okay, you need that.
You don't need to necessarily run it. So maybe the solution could also involve multiple proxies where you have a proxy for ship nodes that are public that this can connect to, because then you can separate the requirements, because currently running a ship node is heavy compared to anything else that you need for this RPC endpoint that just needs to kind of, relay information. And I'm not even sure why it needs ship, to be honest, because unless some of this data cannot be gotten outside the history solution. But that ship could instead have that ship proxy we talked about. And then the proxy of BPs or of node operators had nothing to do with these people running ship infrastructure, because the RPC code will automatically connect to the ship proxy.
So I agree with this.
Public API, if you're going to run like EVM and have swaps and stuff like that, at least from the traffic that we see on our public API nodes, they're just going to smash and smash and smash because they're trying to, do that. So yes, the ship is the most intense, but no, to be honest with you, dealing with the nasties and load balancing and having the public API presence responding to whatever, in our opinion, is actually probably more intense than just running a ship node that's feeding.
Yeah, but it's a slightly different skill set. But I agree with Shaq.
You can have both. The proxy for the VP, for the normal API RPC can, have some type of, checking if the C user is abusing, ban them for a few minutes, and, that. Those kind of dynamic firewall solutions that can all be handled at that level, where the end user is not managing that. The load balancer itself is managing the list of bans, kind of limiting access from abusers. And then you have the people running ship nodes. They also have a proxy. That way, so many more people can run the RPC node, because then it would be super light. There's nothing really in terms of database or state that you need to maintain and grow over time. You just need allocated CPU and you're more or less done.
Yeah, so I guess two more things that came out of Shaq's comments here is one, in the graph ecosystem. So I'm going to diverge a bit. There is a momentum to split the who's providing the infrastructure from who's providing the graphs or the subgraphs. So you can look it up. There's a forum proposal. It's under discussion. So the ship providers and the RPC providers, two different things. One person can do both. The other thing is, are we talking about building paid solutions here? Right? So why does it all have to be free? Are we going to come up with a way, maybe we should be having paid providers and working through it that way? Like the Infura for EOS EVM, which could be, somebody on this call.
Yeah, it could even be a similar one where you get free for, these many calls a day.
Yeah, exactly.
Which is for the average user. And for abusers, they have to, use the token. It has its limits.
Yeah, and the way all those works is you get a unique API key, which gives you a unique URL to that provider. So it's like infura.com/v1/ weird random numbers / whatever my RPC endpoint is. Or JSON RPC, so there's no actual thing after that. But anyway, right, so everybody has a unique URL, which you generated from an API.
Centralized backend.
Yeah, exactly. I don't know. There's some options there.
I'm a big fan of charging businesses money, but not individuals.
Well, I think that's kind of
that's the idea, right? If you're an individual and you make casual number of calls, you're good. We don't mind. You can use our endpoint. If you're sending us 50,000 a minute, well, forget it. Hey.
Right.
Great. I just noticed that it is 10 o'clock, so I think this is a good point for stopping this. I have a few key takeaways. One is that I'm going to check in with the product manager who owns the EVM product about doing a guest spot here to sort of do a brief tech talk on EVM and do a Q&A. I think it'd be valuable to have sort of the node operator perspective, asking questions and getting answers. Yeah, and the other ones I've said a few times, so I won't repeat myself, but thanks everybody for participating and for a frank discussion. Always a pleasure. Learn a lot from these calls. And with that, I'll turn it over to Daniel.
Thank you very much, Brian. Thank you everyone for the discussion. It was great digging more into EOS EVM, and looking forward to continuing next week. See you, everybody.
Cheers, everyone.